Okay, the last conic is a parabola, and you've studied parabolas before, but not from this perspective. We're going to look at the geometric definition of a parabola today. What you're used to from your algebra classes is studying parabolas as quadratic functions, right? So you're used to functions in the form f equals ax squared plus bx plus c. That's the standard form of a quadratic. But then you also have the vertex form, a times x minus h to the second power plus k. We're going to throw both of those out the window. We don't need either of those functions for this new approach to a parabola, okay? So remember, a geometric definition of something typically is going to involve distance, measurement associated in the definition, okay? So here, the geometric definition of a parabola is a collection of all points in the plane that are the same distance from a fixed point, F, your focus, as they are from a fixed line, D, your directrix. Okay? So if we're looking at the picture here, the red curve is obviously your parabola, and then you have a focus point, F, there. Notice it's inside of the parabola. That's how I'd like to describe it. And then you also have this horizontal line for the directrix. Thank you. Okay? All right, so let's look at this illustration here that's showing us this definition. Okay, so notice if I measure the distance from the focus to that point P on the parabola, and then I measure the distance from that point P to the directrix. Notice how those are the same lengths, same distances, okay? And it doesn't matter which point I pick, those two distances are going to be equal. They're not constant distances, but they're equal to each other at any given point. All right. Now, notice when we are measuring the distance from the point to the directrix line, it's the length of the perpendicular line segment to the directrix line. Okay. All right. So let's use this definition to help us derive an equation for a parabola from this perspective. Okay. So in the picture here, I'm going to label F as the point 0, P. I'm going to make point P just a generic XY. Okay. And what I'm doing is I'm looking for these two distances. All right. So I need the distance from point P to point F, and I need the distance from point P to that directrix line, and we got to think of that segment as perpendicular, yeah? All right, now I need a third point to make this happen that's on the directrix line. So right here, that would have to be the point X, negative P. All right, now why? Well, it's directly below point P, so it's got to have the same X coordinate, right? But why negative P? Well, the equation of this directrix has to be y equals negative P if the focus point is 0, P. Why is that? Well, there's a vertex here on the parabola at the origin, right? So that means there are P units between the vertex and the focus. By definition, there has to be P units between the vertex and the directrix then, right? So that means I have to go P units down, okay? All right, so what I'm going to do is find the distance from point P to F, and that should be equal to the distance from point P to that directrix line D, all right? So from P to F, using the distance formula, I'll have the square root of x minus 0 squared added with y minus p squared. Everybody okay with that? All right, now, what about the distance from P to the directrix line? Well, that's the distance between this point xy and x negative P. Well, the x coordinates are just going to wipe each other out, right? So really, the distance or the length of that perpendicular line segment there is just the difference of y and negative P. So I can say y minus negative P. But I need to make sure this works for all situations, not just the picture in front of us. So sometimes if you were to do y minus this negative P value, you'd end up with a negative number. Okay, well, this is supposed to represent a distance, right? So how do I handle that? Just some absolute value. Okay. All right, now let's manipulate this. I'm going to square both sides. Actually, how about we clean this up first? Let's make this square root of x squared plus y squared minus 2yp plus p squared equals the absolute value of just y plus p. Okay, now if I square both sides, the radical clears. And then think over here, is the absolute value important if I'm going to square over there? No. Because squaring a positive or a negative results in a positive, right? So I can effectively ignore the absolute value at this point. Okay, let's expand that right side. Okay. Now, I'm seeing there's some terms that are going to cancel here from the left and the right side. What are they? P squareds are gone, and the y squareds are gone. Okay, now how about I just add this 2yp over, and I'll end up with x squared equals 4yp. So sometimes you will see an equation of a parabola by this geometric definition written like that. Our textbook actually reverses it. They solve for the linear variable. So if I solve this for y, I'm going to think of it as y equals 1 over 4p times x squared. So this is the version we're going to use. And what did p represent? It was a distance from the vertex, which was the origin, to the focus and to the directrix, right? That's how we set it up. Okay? So you will see that equation on the next page. I have y equals 1 over 4p times x squared. And there's two possibilities when the equation is in that form. Okay? The parabola could open up, but it also could open down. All right? So it's going to open up as long as the p value is greater than 0. Because think, if p is positive, the coefficient on the squared term is positive value as well. All right? But if I make p negative, we're going to open down. Negative coefficient would reflect us over the x-axis. All right, your vertex is just going to be the origin for now. Your focus, the point F in blue there, would be at 0p. And that would make the directrix, that horizontal purple line there, y equals negative p. All right, now the only other thing we're going to need to include on our graph is what we refer to as our focal chord. Okay? Our focal chord is a line segment that passes through the focus and has endpoints on the parabola. Okay, so this would be our focal chord. And we have a property. The length of that focal chord is always 4p. Now I'm going to say the absolute value of 4p though, because sometimes p is a negative number. Questions there? Okay, now look at the right side. We could have the parabola open to the left or to the right. We're not used to that. When we study parabolas from an algebraic perspective, we always have them opening up and down. Why?
They have to be functions.
They got to be functions, right? We make such a big deal about functions in algebra. Well, here in the conics, we don't really care whether something's a function or not. All right? So if we want these parabolas to open left or right, now it would be the y variable that's getting squared. Okay? So we're going to open right when y is squared and p is positive. We'll open left when y is squared and p is negative. We'll still say the vertex is the origin. Okay, so if we're opening right, that means the focus is to the right of the vertex. So now it's going to be at P0. The directrix will now be a vertical line of x equals negative p. And here would be your focal chord. Still has a length of the absolute value of whatever 4p is. All right, so let's look at some examples. Y equals negative 1/8 x squared. Just by looking at that, you should be able to tell me which direction it opens. What do you think? Opens down. Why? Has a negative coefficient. That's one thing to focus on. So why not left?
Because x squared is being, or x is being squared.
X is being squared, yes. So there's two things that are telling me it's opening down. Negative coefficient and the x variable is being squared, okay? Now, I can take that negative 1/8 and I'm going to set it equal. Our model has the coefficient as 1 over 4p, right? So what does that mean p is? It'd be negative 2. So notice the fact that it's negative also is telling me we're opening down. Vertex is the origin. Okay, so if we open down and p is negative 2, go 2 down from the vertex. That would place my focus at the point 0, negative 2. I'll go 2 up from the vertex to get to my directrix. It'll have to be a horizontal line of y equals positive 2. And then the length of the focal chord, if we figure that out, we'll be able to get some other points on the parabola really easily to be able to sketch it. So we said it should be the absolute value of 4 times our p value. So that's the absolute value of negative 8, or 8 units. So that means the length of that line segment that passes through the focus and has endpoints on the parabola has to be 8 units. So knowing that, what I'm going to do is cut that in half. Half of 8 is 4. And I'm going to go 4 units to the right and 4 units to the left of the focus. Can we agree the distance between the 2 red points I just plotted is 8 units? Okay. So now I can draw the parabola. Those 2 red points show me how wide it is. Okay, you don't have to, but you can draw in the focal chord if you'd like. Now, let me verify that those two red points are actual points on the equation. Since they are in line with the focus, they have the same y coordinate as the focus, correct? Which is -2. So use your equation. If you plug -2 in for y and go to solve it for x, you'd have to multiply both sides by -8. That's going to give you 16 equals x squared, or x is going to be plus or minus 4. Okay, so because of the plus or minus, it's showing there's 2 points here. +4, -2, and -4, -2. And look at the 2 red points I already have plotted. Those are the coordinates. Okay? All right, so understand, what I just did in red there, you don't have to do that every time. I'm just verifying that the 2 red points I got by using the focal chord length are in fact solutions to this equation. Okay? Any questions? All right, example 2. Which way are we opening? I heard down, I heard left. Somebody's right. Yeah, it's going to be left this time. So it's still a negative coefficient, but now y is being squared. Okay? I will take 1 over 4p. I'll set it equal to -1/2 to figure out what p is. Some of you may struggle with how to solve that. Just treat it like a proportion. You could cross multiply. You could say 2 is equal to -4p, making p -1/2. Okay, so the vertex origin. All right, now, let's see. We've got, p is so small there, I think we may want to change our scale. How about we make this -1, -2, etc. And we can make this 1, we can make this -1. All right, so our focus is going to be at -1/2, 0, which is right here. Our directrix would be a vertical line at x equals +1/2. And then the length of the focal chord, absolute value of 4 times the p-value of -1/2. So that's the absolute value of -2, or 2 units. Okay, so from the focus, I'm going to have to go up half of that length. So half of 2 is, of course, 1. I'm going to go up 1 unit and down 1 unit to get to my 2 points to make the focal chord. Right here is that focal chord. All right, now once again, I can verify those 2 points that I just plotted for the focal chord. They have the same x coordinate as the focus. So if I were to plug -1/2 in for x into the equation, I would multiply both sides by -2. I'd end up with 1 equals y squared. Y is plus or minus 1. So notice by plugging -1/2 in, you could get 1, or you could get a second point where the y is -1. Those are, in fact, the 2 points that we have plotted here. All right, final example of the day. Graph and find an equation of the parabola whose vertex is at the origin, focus at 2, 0. So plot what you're given. There's your vertex. There's your focus. Right there, that tells me which way is this one opening. To the right. It also tells me what's my p-value. 2. Okay, I can reason out my directrix should be 2 units to the left of the vertex. So it'll be a vertical line at x equals -2. Focal chord, absolute value of 4 times our p-value of 2. So that's just going to be 8 units. So from the focus, cut that in half, go up 4, go down 4. Here's the parabola. Okay, so we just need to make the equation for this. Well, since we're opening to the right, our model would be x equals 1 over 4p times y squared. So that would be x equals 1 over 4 times 2 multiplied by y squared, or x equals 1/8 y squared.